It's been 3.5 weeks since Snowmageddon 2023 occurred, so this is going to be a review of the storm, the response, and the forecast that I put out. I know I promised this about 3 weeks ago, and I'm sorry it's so late, but it is better late than never, I guess. So, some records and significant milestones that occurred with this particular storm. I will have a bigger portion of this at the end of the video, what I'm going to call the stat attack. The Portland snowfall, there was 10.8 inches that occurred in the National Weather Service office, which was the snowiest February day on record, the second snowiest February on record, and the second snowiest day, calendar day on record, where January 21st, 1943 had 14.4 inches. That is the number one spot. This is not to be confused with the 24-hour record. I could not find the data on where it ranks for 24-hour snowfall, but I do believe it is top 5. This is also the second latest below freezing high, which was 31 degrees that occurred on Thursday, the 23rd of February. The latest was on March 3rd, 1960, with 29 degrees as the high on that day. So there is at least some precedent that it has gotten this cold this late. This was also the coldest end to February on record. So the metro snow totals that occurred, this credit where credit is due. One of the meteorologists that is in my Portland meteorology group created this map, and he has given me permission to use this in this video, so full credit goes out to him. So areas in the far southeast metro area, mainly rural areas of Clackamas County and Estacada, received generally an inch of snow or less. Some areas only recorded a trace of snowfall. Areas on the southern fringe of the metro area like Oregon City, Canby, West Lynn, plus a donut hole centered just to the north of Salmon Creek and a little bit south of Richfield, had anywhere from an inch to 3 inches surrounding that donut hole in the greater Vancouver area, and then again in the south central part of the metro area and had 4 to 7 inches. The majority of the metro area had between 8 and 11 inches, though portions of the metro area, specifically downtown Portland, received less than that, and some areas received 12 inches or more, like the areas around Gresham in the hills, north of Camas and Washougal, and to the west of Scappoose. For more specific snow totals, I put together this table, and while I couldn't get all the locations on here, I got a good variety of locations, which was the goal here. So on the coast, anywhere from about an inch to a foot was typical, with the biggest winner in terms of snow totals was Tillamook at 11 inches near downtown, and the lowest snow totals was around Astoria with only about an inch or so there. In the Willamette Valley, totals range for about a trace in Eugene. You didn't really get snow if you were south of a line halfway between Corvallis and Eugene, going across the entire Willamette Valley. This again also existed in the rural parts of Clackamas County as well, so areas there did not see much snow as well. Otherwise, anywhere from about an inch to 4 inches was pretty typical until you got to areas like McMinnville and Newburgh, where both areas there I saw 5 inches as the average report based on the public information statements in other reports. For the areas around the metro area, again, not including all locations, for example, Hillsborough got 10 inches but it's not included in this chart. Beaverton and downtown Portland both got 7.5 inches, though areas not too far from these stations did receive more than 7.5 inches. Further south you go, the less you got. Oregon City only got an inch. Areas in the Far East metro area scored, where Gresham got a foot. The National Weather Service almost 11 inches. Camas 9 inches. And then also areas further west scored as well. Forest Grove, Hillsborough, again, both got about 9 to 10 inches there. And even here where I'm at on the western side of Sherwood, because I did hourly measurements, I recorded 9 inches, but only 7 inches of that actually stuck to the ground. The snow accumulations were so heavy that I was actually able to take hourly measurements for a good 5 to 6 hours. So that's why that difference is there. I do suspect part of that's also because we were on the eastern edge of the second convergence zone. I'll go more into that as we go later into the video. I suspect that as the easterly winds blew into Sherwood, that blew some of the snow that accumulated further westward. And then also, as snow falls, it can compact after it touches the ground and more snow accumulates on top of it. So I do think that's something else that occurred. 9 inches is what I'm putting as my official total, though. Event notes, this was very dry snow for Portland. I keep hearing this 0.84 inch liquid equivalent total being tossed around, which was the liquid equivalent total for the day. However, the first 0.15 of an inch fell as rain. So that leaves 0.69 of an inch that fell as the liquid equivalent for 10.8 inches of snow, which is a 16-to-1 ratio. So if 16 inches of snow melted, that would equate to about an inch of rain that fell. The average for 10.8 inches of snow is about 1.08 inches, so a 10-to-1 ratio. So this was far drier than normal. A median ratio is closer to an 8-to-1. We typically see more wet snow than dry snow, but when we do see dry snow, it tends to be pretty dry. About half of the snow fell when the temperature was 34 degrees. So to buzz the second myth of this video, the air temperature does not have to be 32 degrees for snow to stick. The ground temperature has to be 32 degrees, and even if the ground temperature is slightly above 32 degrees, as the snow falls, it can cool the ground enough to bring that to 32 degrees or below. Therefore, snow starts to stick on the ground, and that's what occurred, even though the air temperature was 34 degrees before about 4 p.m. This is the biggest 24-hour snowstorm that I have seen. If you were in the East Metro area, since about 1943, though Far East Metro area, there was a bigger snowstorm in 1980. The Central Metro area, 2017. If you were in either Clark County, excluding Camas, and the Willamette Valley, 2021 had a bigger snowstorm. And while I don't have accurate figures for the West Metro, it did exceed the numbers that I have on file for 2017, except in Beaverton. The days after. Thursday the 23rd, from about 3 p.m. to Saturday the 25th was dry. Sunday had a trace to 0.3 of an inch of very wet snow, almost slush, that changed over to rain pretty quickly, with most locations receiving a trace. Monday was mainly dry, some isolated pockets of some snow and rain here and there. And Tuesday, if you were west or south of the metro area, you generally saw another inch to 2 inches, except Dallas, where you saw 3 to 6 inches there. And while I don't have it on this slide, the snow threat remained for areas in the far South Valley until about March 10th, though none of the impacts were significant beyond Tuesday, the 28th. So what went right and what went wrong with the setup? I'm going to do what I forecast in red and then what actually happened in yellow. So I forecasted a low pressure system to move off of the British Columbia coast and park itself right off of the northern Oregon coast, depending on which video you watch. I either said the mouth of the Columbia River as a location or right about at Cannon Beach as a location. I'll put it in the middle here for reference. And that would stall during the day on Thursday and a little bit during the overnight hours on Thursday night before starting to sag southward later on Thursday night and moving out to sea somewhere around the Oregon-California border. What actually ended up happening is that the first part of the forecast ended up being correct. It did slow down and stop for a bit, on Wednesday morning, but the low started to meander a little bit inland. And meandering for stalled lows isn't unusual, and even the meandering of about 40 miles inland isn't entirely unusual, but is on the upper end of what we typically see for meandering lows. This put the low pressure system actually pretty close to the Kelso and Longview areas, and someone asked in the comments of a previous video, because I forecasted a convergence zone if this low pressure system moved north or south, if that would move the convergence zone. And the answer I gave was no, it wouldn't, unless if it moved significantly further north or significantly further south. As it moved east, though, that does give it enough force, or in this case, does not give the east wind enough force to bring the easterly winds all the way over to the western metro area yet. So you just get the southerly winds moving up through the Portland metro area, meeting with the easterly winds coming out of the Columbia River Gorge. And that's why the first convergence zone formed over the east metro area. During the evening hours, the low pressure system kind of reformed and moved out to the west and set up back near the original low spot right off of the mouth of the Columbia. And that moved the convergence zone back to where my original forecast spot was for the convergence zone, just to the northeast of the Chehalem Mountains. A third one formed just to the southwest of the Chehalem Mountains on Thursday morning as this low pressure system started to move out to sea. And instead of sagging southwards, it proceeded almost due west. There was a small secondary low that occurred on Thursday, and that did bring snow flurries throughout the day to areas, but this was not as significant as the main low pressure systems that I am mentioning here. So the next slide is going to be a radar image showing what happened during the 36 hours, and you could clearly see the first band of moisture what looks like is stalling over the eastern metro area, but in actuality it's the southerly moisture-rich winds meeting up with the easterly winds coming out of the Columbia River Gorge. They meet here, and that's not a single band of moisture. That's moisture getting essentially regenerated over and over again for hours on end, and that's why the eastern metro area had a lot of snow get dumped on them from about mid-morning on Wednesday through the evening hours. A little bit break during the evening hours, while a second convergence zone ended up forming just to the northeast of the Chehalem Mountains as a second band moved up from the south, as you saw in this loop. And this held here for about 5 to 6 hours, bringing heavy snowfall to those areas, before on Thursday morning a third convergence zone moved just to the west and south of the Chehalem Mountains. Since that low pressure system moved a little bit to the west, that gave the easterly winds just enough force to go over the Chehalem Mountains, but not enough force to bring it further south into the Willamette Valley. The Chehalem Mountains is a significant blocking factor, and you need a lot of force to get over those mountains, even though they're not as tall as the Coast Range or the Cascades. So that's what happened. To give a model analysis on what occurred the nights before, this first one occurred was released at 10 a.m. the day before, giving essentially a 36-hour warning before the snow really started to accumulate. According to this model, it showed the total snowfall by Thursday at 5 a.m. to be about 2.5 inches for Portland at a 10-to-1 ratio, and about 5 to 7 inches for areas in the Willamette Valley. For the 10 p.m. update, aka a 24-hour heads up, it moved the prime snow area to the Portland metro area, having most of the metro blanketed in 6 to 9 inches by the time you would have woken up Thursday the 23rd, which would have translated to about 10 to 15 inches of snow at the actual snow ratio that occurred. The valley was still in a reasonably high snow total for them at 3 to 5 inches, though less than before. And while this did go down further for the Willamette Valley, and also went down to Washington County to 2 to 5 inches for there, and anywhere from a trace to 2 inches for the Willamette Valley, the Portland area, if you are in the populated regions of Multnomah and Clark County, you are still in that 6 to 9 inch range. Now, personally, this is just one model. There are other computer models that did different things with this event. I personally find the Euro model to be generally more accurate, but not always. And this is to show that, okay, computer models aren't always accurate. Like, for instance, this run better showed that Washington County really could get hit, but it overdid the valley totals, and vice versa with this. So this is lesson: never to blindly use just a single model run. And I don't like to do that, and I heavily use a geography based forecast for what I posted to Monday night, Tuesday night, and Wednesday during the day on my forecasts. So how did my forecast perform? I'm going to put a disclaimer that I was an idiot and decided to delete the slides right after I posted the video. So as a result, I took a screenshot from my YouTube video, and, well, this is the best I can do. So here you go. The video I put out 2 days ago, I forecasted widespread totals 1 inch to 3 inches Wednesday night into Thursday, regardless of where you were in the Willamette Valley. However, I did note that areas further north may receive less, which was the case once you got further north of about Salmon Creek, minus another higher total area right around the Kalamatta Longview corridor. And I did, however, forecast that this was a pattern that would likely see some area score a significant amount of snowfall through a convergence zone. I forecasted that this place would most likely be somewhere around the Chehalem Mountains, but it really could have been anywhere in the Willamette Valley, because I know that this was difficult to forecast more than 24 hours out and can be as narrow as 10 miles wide. For a little bit of bragging here, I am proud that I did forecast the location of at least the second and third convergence zones more than 48 hours before they set up. So definitely pretty proud of that, although I did miss the first convergence zone. While I did note that a rain-snow mix would occur in heavier bands on Wednesday, I did not foresee that it would be completely snow, especially in the eastern metro area. And I did also predict the below freezing high that occurred on Thursday. Now, for the day before heads up, aka Tuesday night's video, again, screenshot from my YouTube video because I was an idiot and deleted the slide and also the map as well. But this was the forecasted snow totals I put out: 1 inch to 3 inches in the eastern metro area, with a little bit of a warm tongue around Beaverton, bringing lower snow totals there. A convergence zone centered somewhere around the Chehalem Mountains. I put it right around the summit of the Chehalem Mountains as kind of my mean zone, but I said the margin of error would have been about 10 miles north or south. And going back to the previous slide where I said the convergence zones can be as narrow as 10 miles wide, the radar show that if you moved about 15 miles north or south of the convergence zones, you move from about an area of 10 to 12 inches down to about 1 to 2 inches. So that was pretty accurate. The rest of the Willamette Valley, I forecasted 2 to 5 inches with some isolated totals up to 7 inches. That isolated up to 7 really didn't occur, however. The day of video, and I was smart enough to actually keep this map, so you get no awkward screenshots in this case. I widened the 4 to 9 inch area with isolated totals up to 12 inches for essentially the metro area that currently saw 4 inches or more on the ground, which included Clark County minus the donut hole, areas from essentially Gresham northward east of 205 as well. I, however, kept the convergence zone over the Chehalem Mountains, saying that that convergence zone will move to the west and reform over the Chehalem Mountains, which is exactly what ended up occurring, and actually got the timing almost down to the hour as well, which again, pretty impressed by with how significant this event was. I did forecast the valley that would have 2 to 6 inches, which was an overestimation, especially if you were south of the line. I'd say right around Junction City is where that really happened, and then again around the rural areas of Clackamas County. Otherwise, it was generally accurate. I'd say for the 4 to 9 inch range, you could really cut the swarm tongue out. Otherwise, it would be pretty accurate. So overall, it was not a bad forecast, but there were some things that I could improve on. But let's start with the good. I correctly predicted the Chehalem Mountain convergence zone 48 hours or more before it set up and before major models caught on to it. This was shown in the first run. The models flipped, then not shown again for the day of the event. So again, very proud of that. I also correctly predicted the sub-freezing high on Thursday and was within 2 degrees on Friday, too warm, and Saturday, too low. In tandem to it, risk of shutdown in areas with snow, especially in that area of the convergence zone, was pretty high. On the day of video, I did correctly adjust the forecast, noting the secondary peak in the western metro area, bringing heavy snow, though it was slightly less than the eastern metro area. Even though I kept it in that 4 to 9 inch range, it never got up to the isolated up to 12 inches like the eastern metro area, mainly around Gresham and the lowlands. The bad. I overdid the far south valley, where Eugene only got a trace, and the southeast metro area, as most only got a trace to an inch, but got most of the other populated areas correct. East Valley was another example, mainly Clackamas County. Again, Molalla only got a trace. I did need a day of video to get the forecast correct for the eastern metro area, which is not ideal, and the coast was absolutely abysmal. I forecasted on the second video the more aggressive forecast, 0 to 3 inches, and it was actually more like 1 to 12 inches. Sunday, I also underestimated the southerly winds, causing an overestimation in snow totals for Monday and Tuesday. Monday, he did say that most areas would be on that lower end. Turns out everyone was on that lower end of trace of 2 inches. And on Tuesday, that was a relatively good forecast. So would I have changed my forecast? For Tuesday's video, I stand by that. Granted, hindsight's 20/20, but again, I stand by it. At the time of the recording, the models did not flip yet. In all fairness, I could have come out with a video at 1 or 2 a.m. detailing this flip, but I kept on the conservative side, deciding not to release one. And because my forecast was geography based as well, only really using the models for the position of the low pressure system as a guide, but not as the official forecast, I decided it was better to not release a video. However, on Wednesday's video, when it became clear that, yeah, I've screwed up a little bit, at least, I still stand by that forecast as well, because it was relatively accurate from that point on. Again, minus the areas that I mentioned in Clackamas County and the far south Willamette Valley, and was especially accurate around the Chehalem Mountains. Marginal events beyond, Sunday was the only day I would have changed, mainly to better account for south winds, because, I mean, great, again, hindsight's 20/20, but going forward, that is definitely something I will try to account for a little more going forward, though we have seen snowfall with southerly winds that have occurred as recently as December of 2021. So as a side note with the traffic, and I do feel like I need to address this because freeways were ground to a halt due to the snow. This was caused by a significant number of people that did not leave work or school once it became clear that it would snow more than 2 inches right around noon. I'm not blaming anyone in particular, because I know that for many people it was out of their control and they could not leave work or school until they were done for the day. So perfectly fine. However, it is my personal opinion that it doesn't help that Portland's freeways are either over capacity in the case of I-84, go over shaded hills in the case of Highway 26, or are not even up to interstate highway standards in the case of I-5. Even in the most perfect of conditions, these roads experience traffic. When you add a significant weather event, like a snowstorm, to this, it reaches their traffic tipping points far earlier, therefore getting congested earlier and causing accidents a lot easier, hence the stranded cars. Now, this screenshot was taken at 12:51 a.m. on Thursday morning, and most of the Portland area freeways were still almost at a standstill. And some areas are going so slow that Google recorded the roads as closed, even though I don't think most of these roads were. They just had abandoned cars and cars at a complete standstill. That's how bad the traffic was. However, you only need about 1 inch to 2 inches for significant traffic impacts to occur. And because there was rain the days prior, de-icer does not work well on previously wet surfaces, so there's not much PBOT or ODOT could have done to help the situation. For what I mean by a few inches can do something, let's go back to the previous snowstorm that occurred on a weekday, December 14th, 2016. Now, we have had more recent snowstorms, but we've been pretty lucky that they've either occurred during holidays or during weekends, at least in the Portland area. That's not the case when you go further south towards Corvallis and Eugene, though. This storm caused the worst traffic impacts prior to this one, in my opinion. However, this snow was forecast, days ahead of time, with the National Weather Service forecasting 2 to 3 inches of snowfall for the Portland metro area, and the official total was 2.3 inches. 20-minute commutes turning into 7 hours was pretty normal, and I will have links in the description for how this progressed if you want more details on that event. So again, you don't need 10 inches plus of snow to get significant travel impacts. You generally only need 1 is when you really start to see it. 2 is when a city shutdown becomes almost certain. So that is it for the recap of the snowstorm and the response. The next portion of this video will be going over the stats of the storm, specifically in a graphs and charts format, mainly just for the Portland area because that's where all the records occurred. Snowiest February's on record. Again, 2023 was second place with 10.8 inches, only falling on one day. The record is in 1949 with 13.2 inches of snowfall. And as a note with this chart, 3 of the 5 snowiest Februaries occurred in the last 10 years, which signifies at least a recent trend towards snowier Februaries. We'll see if that holds as we go into the future. Snowiest calendar days on record. Again, the snowiest calendar day was January 21st, 1943 with 14.4 inches. Second snowiest was what occurred on February 22nd with 10.8 inches. Previous second place, now third, is at 9.3 inches. And rounding up the top 5 was totals that round to 8 inches. To bust the third and final myth of this video, I've heard around in meteorological circles that it's hard, if not impossible, to get a snowstorm or Arctic air into the Portland area after mid-February, and it's impossible to shut the city down for days on end. So yeah, if this snowstorm didn't prove that wrong, the March 8th snowstorm did before, because 8 inches is more than enough to shut the city down for at least 2 days. It does take a little while for that to melt, though the highs were above freezing for that, so the shutdown was for not nearly as long as what occurred this snowpocalypse in 2023. For the snowstorms that occurred by month before the 1980 to 81 winter, as a note, that is the halfway point in the Portland Airport / National Weather Service data. The 1980 to 81 winter was snowless, however, so that makes the halfway point a little easier to quantify. So in November, 4 snowstorms occurred. December, 10 snowstorms occurred. In January, a significant peak with 30 snowstorms occurred during these years. In February, only 4 snowstorms occurred. And in March, 2 snowstorms occurred in Portland. Now, after the 1980 to 81 winter, the months of January and February did see some significant changes. To start, January fell from 30 snowstorms down to 9, and only one of those have occurred since 2010. And February had a huge uptick from 4 snowstorms to 13, over tripling its previous amount. And in December, not much has changed. It's at 12 snowstorms compared to 10 before. That's not statistically that different. And while March has had no snowstorms in the Portland area, there have been snowstorms that have occurred further south into the Willamette Valley, and similar to no snowstorms in November, but there has been 2 major Arctic blasts that have occurred in the 40 years since 80 to 81 in November. So you can get winter weather in both November and March, even though it doesn't appear to be by here. As a note, 2 inches is the cutoff for a snowstorm. The number of 6 inches of snow or more in a winter. Before 1981, there was 17 winters that had 6 inches of snow or more. And since 1981, there has been 16. So not statistically different. Now, this contradicts something that I say in my long-range predictions video that I've said the snowfall has been decreasing before the 1970s and have leveled out since then at about a 43-inch per decade average. This is because before 1981, there was a lot more extreme winters where you got winters more than 20 inches. We've only had one winter with more than 20 inches since 1970. So those extremes have gone down, and even though the number of 6 inches or more haven't, and since that extreme has gone down, that explains the decrease in snowfall. And by the way, why I chose 6 inches of snow for this cutoff, that is the upper third percentile of all the years Portland has experienced, rounded to the nearest inch. And in the meteorological world, we consider that upper third to be the above average category, the middle third to be near average, and the below average to be the bottom third. Now, for the first 3 winters of each decade, the 2020s have had a really active start. We'll see if it holds. 27.4 inches is the snowfall that has occurred at the Portland National Weather Service site during the first 3 winters, which beats the previous record in the 1950s at 22.7 inches. And just to show the potential and why you shouldn't just look at the first 3 winters of each decade, the 2000s had the least snowiest at 0.7 of an inch to start off that decade. Coldest highs in February, and just to better quantify how cold this cold snap was, I'm only taking the lowest high temperature from each February listed. So, for instance, February 2023 had a 31 degree lowest high temperature, which is good enough for 7th place. The lowest high temperature in all of February is 15 degrees, which occurred in 1989. I should note there was more teen highs in 1989, and something I noticed was that all the highs that were in the teens and the 20s occurred during the first week of February 1st through 7th, and then after about February 16th, there was minus the March 3rd, 1960, there was no high below freezing. So if I change this to after February 17th, this was the second coldest high, with only the March 3rd, 1960 date being colder at 29 degrees. Previously, a late season cold snap was considered at its potential if a high temperature got into the mid 30s. Even as early as last year, we got a significant cold snap this late in the season, bringing a high temperature to the upper 30s, though. For the coldest lows that occurred in that same time period, an 18-degree low is the coldest that we saw, and that occurred Saturday the 25th in the early morning hours, which ties the record with 2011. It's not the latest on record, as the 2011 occurrence was a day later on the 26th. Previously, it was thought that the lowest the low temperatures could go without snow cover would probably be in the mid-20s. And while that would likely occur in this case, if we didn't have snow covers, we will never know for sure. Coldest last week of February, all the temperatures are in degrees Fahrenheit, and this broke the previous record by 1.4 degrees, which was set only 12 years ago in 2011, while rounding up the top 5 was 35.3 degrees and right in the lower 36 degrees, which was previously thought to be the coldest that it could get this late in the season. So yeah, it was pretty cold. This is temperatures that you would not expect to see any time during the wintertime. If you saw this, the most likely time to see this is in the middle of January. The last week of February is in the first 6 days of March, and I use the first 6 days of March in particular because that's when a lot of these early March cold snaps ended in 1960 and 2019, and also the 2023 cold snap really lost its grip after the 6th of March as well. It moved 2023 into the third position, especially because the 1960 bar here included that 29 degree high temperature on March 3rd, and 2019 had a significant cold snap in early March as well. And lastly, the longest stretch below 60 degrees, and this is for all of winter, not just in late February. And the reason why I bring this up is the average day of the first 60 degrees occurs on February 17th. So we generally see it. The median occurs in late February. That I believe is the 24th. I'm going off of memory here. I don't have that on file exactly. So late February is when we start to see that false spring occur, or that first taste of spring. But nope, not this year. We've had 131 days below 60 degrees, which that streak got broken this past Thursday, I believe. The previous record occurred in 1992 to 93 with 128 days below 60 degrees. And the keys that I noticed here was you need a cold November and a cold end to the season, which all of these years had. So that is it for this video. So if you watch all my videos, thank you so much for your support and just watching the videos. And since I know it was a very rough time, and thanks for getting through it with me, because it was also very difficult to forecast. So I don't know what the next video is going to be out. There's a significant forecast event between now and October. I will put out more videos on that. Otherwise, just stay safe out there and take care.